This is a diagonal matrix. I have taken a diagonal matrix of order 5 by 5, that is 5 rows and 5 columns. And here you can see that most of the numbers are zeros and only the elements in a diagonal are non-zeros. So the important thing is, other than diagonal, all elements must be zero, then only we say it's a diagonal matrix. Suppose I have some element here, let us say 5, then it's not a diagonal matrix. This must be 0. So the important condition is all those elements must be 0. So let us see how we can define this one. See, if this is a matrix M, then M of ij is 0. If I is not equal to j, M of ij should be 0. If I is not equal to j, then it is a diagonal matrix. If they are equal, then the elements may be 0, non-zero. We don't bother about that. We bother about rest of the elements. All these elements must be 0 and these elements are 0. So these elements are non-zero elements, rest of the elements are zeros. So I have given a definition of diagonal matrix. Now, if I have to represent a diagonal matrix in a program, then for a matrix I have to take two-dimensional array, 5 rows and 5 columns. But if I take a two-dimensional array of size 5 by 5, most of the elements will be zeros. So I'll show it. So like this, if I take a two-dimensional array for storing this matrix, then most of the elements are zeros. If these are integers and integer is taking 2 bytes, then total how many bytes of memory this array is consuming? There are 5 into 5 elements are there, that is 25 elements are there, and each element is taking 2 bytes. Suppose for an integer, then it is taking 50 bytes. 50 bytes of memory it's consuming. So if I am storing this in 50 bytes of memory, then storage of 0 elements is unnecessary. So it is wasting space. As well as when I am processing on diagonal matrices, like if I am adding 2 diagonal matrices, then adding of zeros is of no use. If I am multiplying 2 diagonal matrices, then multiplication with zeros is of no use. So I will be wasting time in processing upon zeros. So the idea here is that we want to store only non-zero elements. So how we can store only non-zero elements? So for only non-zero elements, we can take just a single dimension array and store these elements. So let us see how we can do that. Now let us see how we can represent a diagonal matrix in just a single dimension array. So I will take a single dimension array, let us say A of size 5, because only I have 5 non-zero elements. So I have an array of size 5. This array starting index is 0, but here if you observe, I have taken the indices from 1 onwards. So in mathematics, we start indices from 1 onwards, so that's what I am following. So if you want, you can change the indices from 0 also. Then this array, that is in programming, it is in C programming or in C++ programming, the array starts from 0. So I have taken an array from 0. Now I want to store only non-zero elements. So let us store those elements. 3, 7, 4, 9 and 6. So I have stored only non-zero elements. Now let us see how we can access these elements from a single dimension array. If I want to access M of 1, 1, this element, then it is at 0. If I want to access M of 2, 2, this element 2, 2, it is at 1. So only diagonal elements are there. So if I want to access any element from matrix M of I, j, this I am calling it as M, but it is stored in an array. Then from where I can get the element? First of all, if I is equal to j, then only we have an element, right? So if I is equal to j, then 2, 2 is present at 1, 3, 3 is present at 2. So element is present at I minus 1. Or even I can say j minus 1. So this is very simple. Now let us write a C++ class for a diagonal matrix. So let us take a class name as diagonal. Class diagonal What are the data members or the properties required for a diagonal matrix? I need a dimension. What is the dimension? And an array space for storing the element. So let us make the data as a private. Two things I need. One is dimension n. As it's a square matrix, so just n is enough. We don't need n cross n, mn. We don't need just one dimension. That is same square matrix. If n is 5, it is 5 into 5. Then we need an array. For this array, I will not create an array, but I will take a pointer so that I can dynamically create an array. That's all. These are the two things I need. The next thing I should write on a constructor. So constructor inside public, I will write a constructor for diagonal. So when you are creating an object of this one, then what we need the dimension, whether it is of size 5 or 4, whatever it is. So I need a dimension. So let us take int n. So this will take a dimension. Then inside the constructor, I should set this value n to this one and also create an array. So here this n, so this arrow n assigned with this parameter, and to this a I should create an array of the same size, this size. So new, if I am taking integer type here, then it is integer only, integer of size. I can simply write n also. So I can use either this one or this one. So this is how array is created. So we will get a single dimension array of required size. That is 5 means array of size 5. Let us say this is the 5 size array. Then what are the other functions I need? I need functions for storing the data and retrieving the data. So for that I need functions like setting the data and getting the data. So I will write on those two functions. Void set. So this set will store the data in this array. That is for this matrix. For a matrix, I need to know the row number and column number. So row number and column number as well as element. So it needs 3 parameters. At which row and at which column, what is the element that you want to store? X. Then we need a function for retrieving the data. So the function name, let us call it as get. Then it also needs from which row number and which column number you want to retrieve the data, and return type should be integer because it's going to return the element at that row number and column number. Then we will also have one function for displaying a matrix. So I will write a function called void display. So instead of a display function, we can also overload insertion operator. That I will show you when I write the program. Now last thing is we should have a destructor for destroying this dynamically created an array. So here I should also have a destructor diagonal. That's all, end of a class. Next I will implement these functions outside the class using scope resolution. So here I will write on those functions. First function is set. So void class name diagonal set 3 parameters I, j and x. Then what it's supposed to do? When 3 parameters are given, row number and column number and the element. So if I am giving suppose 9, so I will be giving 4, 4 and 9. If I am giving 7, then 2, 2, 7. Even I may give 3, 2, that is 0. So it should not store 0. So first of all, it should check whether the indices are for diagonal only or not. So if I is equal to j, then it should store the element in A of I minus 1. This is the formula we have seen. Like this is 1 comma 1 is stored at 0. So 3 comma 3 is stored at 2. So I minus 1. I comma j is stored at I minus 1. If they both are equal, so store the element. That's all. This is set function. If they are not equal, don't do anything, don't store anything. We don't have to store anything in the array. Then second one is get function. Return type and the class name. Next is get two parameters I and j. That is which element you want to read, which element you want to retrieve. Suppose I want to retrieve 3 comma 3. So 3 comma 3 means at index 2. That is 3 comma 3 is 4. This one. So I comma j is given. Now here again I can get the data from there only if I is equal to j, just like in set. Same thing we have to do. If I is equal to j, then in the same line I am writing return a of I minus 1. And one more thing, if they are not equal, then definitely the element is 0, so return 0. So these are set and get methods. So I have a constructor, I have set method and get method completed. Now I will write down these two functions. There is no space. I will remove this and I will write down those two functions. Now display function, class name and function name display. Display means actually we have these elements, but we should display it like a two-dimensional array along with its zeros so that it looks like a matrix. So let us display a two-dimensional matrix. So for that we need two for loops. For I assign 0, I is less than n, I plus plus, that is that n. And for j assign 0, j is less than n, j plus plus. Then I have to display the elements. But how many elements I have? Only diagonal elements that are present in the array. So I should display the element if I is equal to j. Otherwise I should display 0. So if I is equal to j, so in the same line I will write down cout a of I minus 1. Otherwise cout 0. So whatever you want to display, you have to give it in double quotes if it is not a variable. So I want to display 0. So 0 is given in double quotes as a string. Then close this one. This for loop will display one row, and after every row I should go into the next line. So cout and L. Then close for loop and close the function. So this function using two for loops will display a two-dimensional array like this. Then I have this last function, that is destructor. It should have just a simple statement, so I'll explain there only. Just I have to say delete this array A. The one that is dynamically allocated, it should be deallocated. So just as a single statement inside that function, so I have expanded there itself. So that's all for our diagonal matrix. We'll be learning about more matrices like a lower triangular and upper triangular. In all those matrices, we will be having same set of functions in a class. I will not be writing a complete class every time. Then we have to see the other matrices like lower triangular and upper triangular and so on. For every matrix, the class looks similar. We will be having dimension and our square matrices, and we'll be having array space, and we'll be using single dimension array only. And we need a constructor, set and get function, and display and destructor. And while writing a program, I will show you a complete class.